Hi, everyone. My name is Holly Smith, and I'm with the Center for Land Use and Sustainability at Shippensburg University. I'd like to welcome you to our webinar tonight called Tracking Wildflower Climate Resilience with AMC, Tap into Community Science with iNaturalist. We're really excited to have some folks here from the Appalachian Mountain Club and so thrilled that they joined with us to create this evening for you so we can get some folks out on the trail and helping them with their research. With me here tonight is Dr. Nathan Thomas. He's an associate professor of biology at Shippensburg University. He's also the Center for Land Use and Sustainability faculty liaison. We also have from the AMC Morgan Southgate and Georgia Murray, and Nathan will be introducing them in just a few minutes. A couple of housekeeping. If you have any questions during the presentation, please share them in the Q&A feature, which should be on your bar and available to you. The chat has been disengaged for you. However, we might be sending some things out through the chat as the evening progresses. We are recording this webinar. You'll receive a link to the recording in a couple of days. It will also be posted on the Center for Land Use and Sustainability's YouTube page, so you can access it there. And to start out, let's find out who's in the room today. I'm going to launch a very short two-question poll and see if you could share with us your affiliation. Pick one. I know there's many of you that have many affiliations, so pick the best one that suits you, and then the state where you're coming from. Go for just a couple of minutes. Okay, that sounds good. Thanks, everybody, for sharing that information with us. That's really helpful. We have a couple of folks from New York, Pennsylvania, Maryland, West Virginia, and some other states, which is great. Thanks for joining us. Okay, let's share some results and we can see who's here and how what your affiliation is. And there's the states where we're from. So. Okay. I'm going to share a little bit about the Center for Land Use and Sustainability, affectionately called the CLUS. I think I am anyway. There we go. The CLUS is part of Shippensburg University, and we function, our goals are to foster healthy, vibrant, and sustainable communities through applied research, experiential learning opportunities, and interdisciplinary partnerships and projects. We leverage our team of interdisciplinary faculty and students, and we promote sustainable land use, economic development, cultural and natural resource management, and a sense of place with our students and with the community. We bridge our university resources and talent with community partners, agencies, and organizations to develop high-quality research projects, products, and events. And we provide opportunities for students to exercise and apply their skills in professional situations to build their networks and engage with community partners both regionally and beyond. So we really enjoy working with partners, as you can tell, and enjoy getting our students involved in real-world projects and research. So we also promote sustainability on our campus with our composting program, our food waste assessment and dining hall education, riparian buffer management, lawn conversion initiatives, and greenhouse gas tracking. We also have a campus farm, very small and very functional and engaged with our community and our students and the local schools. So our campus farm is an educational, research, and outreach facility providing students with hands-on experience in sustainable food and agriculture. Students also engage with food systems in the local community. And finally, We offer GIS and analysis services and mapping services. We have a GIS analyst on staff full-time, and we can provide geospatial data analysis, site assessments, predictive modeling and risk assessments, data integration, LiDAR processing and 3D mapping, and ArcGIS story mapping. So if you're interested in that, please reach out to me. There's a QR code at the bottom that shows a few more of our projects. And Marianne, our project coordinator hiding in the background, has provided the link to that brochure. So now I'm going to pass it over to Nathan to introduce our speakers tonight. Thanks, Nathan.
Sure. Welcome, everybody. I'm happy to be here, happy to have you here. And Morgan Southgate and Georgia Murray will be presenting information tonight. Morgan is a postdoc researcher with the Appalachian Mountain Club. She got her PhD from the University of Vermont, focused on fern ecology, and is working on focused on climate change and spring wildflowers on the Appalachian Trail. Georgia Murray it has been at the Appalachian Mountain Club, as you can see, since 2000, and her primary kind of focus is wildflower phenology, plant phenology, as well as community engagement and focus on climate research with the U.S. Forest Service. So with that, I'm going to kick it to Morgan, who I believe is going to be starting for kicking us off with your piece. So welcome, Morgan.
Thanks, Nathan. Is that screen coming through all right?
Yes, we can see it.
Excellent. Well, glad to be with you, everybody. Thanks for joining us, and I'm looking forward to sharing with you tonight some of our research at AMC for this webinar entitled Tracking Wildflower Climate Resilience, Tapping into Community Science with iNaturalist. So first, we're going to tell you a bit about spring-active wildflowers in eastern forests. And then I'm going to go on to tell you a bit about the fieldwork on spring-active wildflowers that I've been doing for AMC. And then we're going to move to talking about community science and how we leverage community science at AMC to study these plants. And then we're going to give you an introduction to how to use iNaturalist, which is a really excellent community science tool. And we're going to finish with an interactive wildflower phenology section where you'll actually be able to choose different options with some pictures and see what's going on with some different flowers. And then we'll wrap up with a Q&A. So the habitat that I am most interested in for this project are temperate deciduous forests. And these are the most common habitat type across much of eastern North America. These are places that are strongly characterized by their seasonality, right? With 4 different seasons, we've got fall, winter, spring, and summer. And because of this seasonality, light is a very important limiting resource in these forests. So particularly in the spring, plant phenology, which means the timing of seasonally recurrent life history events such as flowering or the emergence of the first leaves, this represents an important balance between avoiding the risk of frost and maximizing the time for annual growth because the growing season is so short. So importantly, this strategy for growth actually varies across the different layers of the forest. Canopy trees are, of course, unlimited by light availability because they're the tallest plants in the forest. But in contrast, understory plants actually lose access to most of their light after canopy closure. So because of this, many understory species actually emerge before canopy closure in order to take advantage of a short window of high light availability. And this life history strategy is known as phenological escape. And it's exhibited by many kinds of plants in the understory, but it's best known for the spring-active wildflowers. And that's in part because they're such a charismatic and notable sign of spring. So phenological escape is crucial for the annual growth of many species. And on the picture to the left here, you can see wild leeks in the early spring. And you can see that these plants are out and photosynthesizing before the canopy is closed, right? If you look in the background of that picture, there's no leaves in the canopy of that forest. So here's a look at some spring-active wildflowers, and this is a set of spring ephemerals. These are the plants whose life history relies entirely on phenological escape. They emerge in the early spring and complete the entirety of their annual growth before the canopy closes in the early summer. So spring ephemeral species that we focus on at AMC include Dutchman's breeches, a very charismatic plant with white flowers. The common name comes from the fact that somebody thought they looked like sort of pantaloons, right? Old-fashioned Dutch pants. And then, of course, there's spring beauty. This is a very diminutive plant, so this picture is quite zoomed in, and it's got these very beautiful, striking white and pink-veined petals. And then trout lily, another very common and beautiful spring wildflower that you're likely to encounter. So trout lily has yellow flowers, and then the common name comes from the fact that its leaves are dimpled, like a trout. And then finally, bloodroot is another spring ephemeral species with very striking white flowers. Here's a look at a different set of spring wildflowers, and these are also active in the spring, but these are plants that are going to stick around for the entirety of the summer. So phenological escape is an important component of their life history, but they will continue to photosynthesize well after the canopy is closed. This includes plants like red trillium, a plant many of you are likely familiar with, as well as blue cohosh, sessile-leaved bellwort, and jack-in-the-pulpit. And then finally, at AMC, we're interested in studying evergreen wildflowers as well. And so these are plants that emerge in the early spring, but actually continue to photosynthesize not just through the summer, but actually into the fall, and depending on where you are, into the early winter as well. So this includes plants like wild ginger, sharp-lobed hepatica, and heartleaf foamflower. So one of the things that we are working to understand is how phenological escape as a life history strategy will be impacted by climate change. And this question arises because with climate change, it's well known that canopy trees are advancing their leaf-out dates in the spring. And so it's important to try to understand how the phenology of spring-active wildflowers is shifting with climate change and what this implies for the dynamics of phenological escape. Specifically, will spring-active wildflowers be able to keep pace with the earlier season imposed by earlier canopy closure, or are they going to lose access to their spring light window? So there's three basic outcomes for the dynamics of phenological escape relating to this question. So first, it's possible that the window for spring wildflower emergence and canopy closure will shift together, right? And that spring phenological window will remain the same. And this is shown in the top panel of the figure to the left. Second, if spring wildflowers advance their emergence more than canopy trees, it's possible that this spring phenological window could actually grow. And that's shown in the middle panel here. And then finally, and this is the situation that would be most concerning for spring wildflower species, it's possible that their spring phenological window could actually contract. And this would happen if canopy trees advance their leaf-out date earlier than spring wildflowers. So, interestingly, recent work has found evidence for both expansion and contraction. And so this is one of the core things we're working to address at AMC. So one of the ways that we're doing this is a field-based project, and for the past couple weeks, that's most of what I've been doing. I've been in the field more days than not, and so I'm going to share just a bit about that project with you in order to give you a better sense for the context of the research that we do at AMC. So specifically, the question that I'm trying to answer with this fieldwork is how spring-active wildflower phenology varies across elevational gradients. And so in order to do this, I am working at two different sites, Mount Equinox in southern Vermont and Mount Moosilauke in central New Hampshire. And both of these are mountains that are quite high and I'm able to sample nearly 1,000 feet of elevation gain. And so what I've done is to set up plots to capture spring-active wildflower phenology across elevational gradients. This is just a simple map of the study area at equinox with lower elevations in purple and higher elevations in yellow. And I've got 20 plots distributed across this elevational gradient. And this is what it's like to be in the field right now. So this is one of our plots at equinox. At every plot, we're resampling once a week and tracking the phenology of all the flowers present in the plot, as well as using a fancy piece of equipment called a lichor to collect data on plant photosynthetic rate. So fieldwork is, of course, an important component of this, but I can only be so many places at once, and my ability to study these questions is limited by the data that I have access to. And so that's really where wildflower community science comes in. So using community science data, and these are data that are generated by the community broadly, we are focused not just on a couple sites, but actually on the entirety of the Appalachian Trail corridor, which runs from Georgia all the way to Maine. And the Appalachian Trail and the corridor and watersheds that surround it provide a really incredible latitudinal transect across the eastern temperate forests in eastern North America. And so the broad question that we address with the community science aspect of our research is how spring-active wildflower phenology varies with latitude across this latitudinal gradient. So to do this, we pull in observations from iNaturalist as one of the core sources. And interestingly, one of our motivations for forming this connection with Kloos and hosting this webinar today is that our density of observations is actually lower in the mid-Atlantic region. And so this is just a heat map of the number of observations by region across the Appalachian Trail corridor. And you can see that it's pretty high in the southern part of the AT corridor, corresponding to the Smoky Mountains, and also very high in the northern portion, so in the Green Mountains and the White Mountains of New Hampshire, but definitely lower in the mid-Atlantic. And so as we move forward in the coming years, we're hoping to add more observations from this area, and that's where you all come in. So for community science at AMC, we're pulling in data both from iNaturalist and the National Phenology Network. So iNaturalist is a crowdsourced platform for species identification and documentation, and we're going to be telling you a lot more about that in a bit. And importantly, this is a platform where observations are just opportunistic, right? You can just be out moving through the world, see something in nature that interests you, take a photo, upload it, and contribute that observation. We're also pulling in data from the National Phenology Network, or NPN. This provides online plant and animal phenology monitoring programs, and this does involve repeated sampling of plots. So the two sources of data are a bit different. But when we combine these phenology data and then also integrate climate data, we're able to build models of wildflower climate sensitivity, which is one of the key tools for addressing questions around wildflower climate resilience. So here's a look at what we're able to do with community science data. So this is a circular plot of the peak flowering day, meaning the day when the most plants are flowering, versus latitude for bloodroot, which is one of the spring ephemeral species I showed you earlier. So moving around this circle is the day of year, right? So it starts at 1 and then moves around from there. And then moving from the inside to the outside of this plot, we're actually increasing in latitude, right? So you can see, as you'd expect, that as you move from lower to higher latitudes, meaning moving from more southern to more northern regions, the day of peak flowering for bloodroot actually increases, right? But you can also see an interesting pattern where it increases a lot more drastically between about 39 and 42 degrees of latitude, right in this area here. So this kind of pattern And teasing this kind of pattern apart is a core component of what I'm trying to do for my postdoctoral research. So with that context of how the research at AMC works, right? Integrating data in the field with community science. At this point, we'd like to pivot and tell you more about how to tap into community science using iNaturalist, which again is an opportunistic tool for making species identifications and observations. So at this point, I will hand it over to Georgia.
Great. Thank you, Morgan. Yeah, so I am going to focus in on using iNaturalist as a tool to help us collect data. Doing community science along the Appalachian Trail really made sense for us, in part. Obviously, there is critical habitat along the Appalachian Trail that groups have worked to protect. And as you saw in the maps, we're not just talking about the treadway of the Appalachian Trail. We are talking about the surrounding corridor. And so it's not just being on the AT to do these observations, it's side trails and communities around the Appalachian Trail that we are collecting data from. And so the Appalachian Trail community that's already out there are a great resource for us. And when we started looking at where observations were happening, we recognized on the iNaturalist app already, we recognized that there were already people out there in these regions, and we could build a project around it. So what's great about the iNaturalist platform is it does allow you to build projects around specific regions. It allows you to assign additional attributes or fields to observations, such as phenophases. And so what we developed was a project that mirrored the National Phenology Network protocol, which Morgan mentioned is the plot-based protocol in iNaturalist by adding these extra fields. And so we'll talk about those in a second. Next slide. So getting started in iNaturalist. Many of you might already have the app, may already use the platform, but I'm going to walk you through some key aspects of creating an account. And there's two ways you can view iNaturalist. There's through the app on your phone, whether it's Android or iPhone. And then there's also the web browser. So through your computer, this is what the screen would look like if you were to go to the iNaturalist page and sign up for an account. Next, I think there's one visual here. And so when you do create an account, we really encourage you to check yes to consent that your photos can be used by scientists, because it really is a sharing app to contribute your observations to science. And by checking these boxes, it allows us to easily use your photos and have them added to our project. Next slide. So this is also a desktop version or a web browser version of the area on iNaturalist where you would find our project. So there are many projects on iNaturalist, and you can, if you're interested in mushrooms or you're interested in insects, you can go into the project section of it's under community, where you would search for projects and find a project that you could work with. We are really encouraging you to look specifically for our project, which is Flowers and Fauna along the Appalachian Trail corridor. And you can see that you would type that into the search box, it would come up, you would select it, and then there's a red box over towards the right part of the screen that says join the project, where you would join. And when you do join, there are additional questions that pop up. Next slide. And that is, do you want to receive updates for the project, which we'd love for you to do, because that's a great way to stay connected and reminded that this project is out there and you're a part of that. And then also the question around, do you want to make your private obscured observation coordinates visible to the project curators? And so the project curators are Morgan and I and our many seasonals, and we're constantly looking at observations that come in. And if you are walking around, let's say your yard, and you make an observation, you might want to obscure that so that people aren't seeing your observations all around your yard. Or if you take a photo of a plant that you're concerned is something that you don't want other people harvesting, then you might want to obscure that observation. When you check yes here, that means that no matter who adds your image to our project, that we will be able to see those coordinates on the back end. The people would not be able to see it presented in public maps, but we could see it in our project. So this really helps us not have to run down, do we have the right coordinates of the observation or not? And that is really important for a mountain-based project because where you are on a trail can make a huge difference, whether it's 50 meters or 100 meters away. But the obscuring process in iNaturalist puts it in a very large grid. And so we wouldn't know exactly where you were if it was obscured. We can come back to the issue of, sensitive plants. iNaturalist does obscure federally listed plants automatically, but it may not obscure some species on state lists. And so it is worth checking to see whether a plant that you're concerned about is obscured or not by iNaturalist. And you can petition iNaturalist to obscure it if it is on a state list, for example. So here you would check yes, no matter who adds the observation to the project, we can have access to those coordinates. Next slide. So this is just the QR code to be able to download the iNaturalist app for either an Android or an Apple phone. And it is important that you download the classic version of the iNaturalist app. And that is because the newest version that just came out within a few weeks, I think it was like 3 weeks ago, does not have all the same features as the classic version. They haven't gotten all the features into it yet. And there are specific features that we use in our project that you need to use the classic app for. So I would encourage you to download the app so you have it on your phone, but please use the classic version. Next slide. So this is an example of what the screen looks like for an iPhone under different parts of presentations of the app. And so it will show you the list of species that you've already collected. And at the bottom is where you would see projects. And that is where, if you didn't join our project right away when you registered on a web browser version, you can still join our project through the app. And so you would click that box down in the corner that says projects. The next screen would show up and you could search for flowers and fauna along the Appalachian Trail corridor, and you could select it there. And so you could join the project through your iPhone or Android phone as well. And again, it asks you some questions as you do that. Next slide. And then to make an observation, you obviously want to find a great place outside to go hiking and hopefully within the AT corridor. So again, as I mentioned, the AT corridor area that we are including in our project is quite wide. So if you were to zoom in here, I am sure you would find areas with great hiking trails. And we're not asking you to bushwhack in any way or go off trail. We want you to stay on the trails as you make observations. But you can plan a hike within this corridor in your region. And then what you want to do then is find a healthy patch of our target species. Morgan showed you a number of those earlier on, but you can, when we share the link to our iNaturalist page, project page, you can see our target list of species there as well, and find a healthy patch of one of our target plants. And then the best way to make observations is to use the app itself to take the photo. We're going to walk through that a little bit. But if you take a photo just using your photo app, you're not going to get the same geotag information that you get with the app itself, which is an important piece of the features of the app. And so we're going to walk through some of the steps to do that. Next slide. So again, here's the screen that you've opened up on your app on your phone. And in order to make an observation, you're going to hit the camera icon that says observe below it, and then take a photo. So at this point, you could upload an image that's already in your photo library. But again, we're encouraging people to take the photo within the app. And so this is an example of a photo that was taken in the Alpine zone. This is one of our favorite plants called Diapensia lapponica that's above tree line in the northern part of the AT. And so we took this photo, and now we're going to go next slide. We're going to show you the fields that pop up once you've taken the photo and you select that photo. So that small thumbnail photo is at the top. You can hit the plus button and take multiple photos at the same location. And we actually do encourage that so that you can get different angles of the plant, that you can get a picture of the close-up of the flowering part of the plant, but also a picture of the full plant. So it's easier to identify if we can see all of the structure to the plant. And then the next field is, what did you see? Now, if you have cell service when you're making this observation, the artificial intelligence in the app will actually help you identify what you see. It's really good at identifying Diapensia, I think because we've done so many observations of it in the northern AT, but it may not always get the species right. Sometimes it gets it to the family or genus level. And maybe that's what you select. You don't get it all the way to species level, but other times it does a pretty good job. The other thing is you could leave this as a question mark. If you're not certain or you don't have cell service and you don't get that AI guess, you could leave it as not sure, or just plant. And you can go back and edit these observations later. So we actually encourage people to, don't guess and try to, figure it out later when you have more time and are back where you have cell service and also have the artificial intelligence to help you. Next. The other thing in this panel that we really encourage you to do is to check the location accuracy. So it's really small, the lettering here, but it says White Mountain National Forest, and then it has a lat long. And then it has an ACC, and it says 25 meters. And so that's the location accuracy of your GPS. And so if you are standing above tree line, you usually get really good accuracy down to 4 meters. I've seen 3 meters. But if you're under a thick canopy, sometimes your GPS doesn't do as good of a job. But we really want to see that location accuracy below 100 meters, and below 25 is even better. So if you stand there for a bit, if you click on that part of the menu, you can actually see the map pop up, and you can double check if you know where you are on the map. But you can also just leave it at 20 meters accuracy. 4 meters, it's you get what you get in the field sometimes, but it's worth checking to make sure it's not way off, like over 1,000 meters. So that's something you definitely want to check. Next. And then we leave the geoprivacy alone, but that is where you could obscure. Before I get to this project's piece of it, I just want to mention that the geoprivacy is where you would obscure an observation. And then, of course, captive or cultivated, we're out there seeing real plants in the wild, so we don't change that. But then we want to put it in our project. This really helps us out as curators of this data to be able to not have to go out and find observations and put it in our project ourselves. If you can do that in the field, that would be great. Go ahead, next. And when you do go to the project section, this is where you would have the list of the projects that you've already joined, and you would toggle that on. This example is toggling on the Northeast Alpine Flower Watch because Diapensia is an alpine plant. And that is when you get the phenological fields popping up. And these fields, again, relate to the same protocol we're using in the National Phenology Network. And you would go through each of these, click on those fields, and you would get a question around, am I seeing flowers or flower buds? Am I seeing open flowers? What percent of fresh flowers am I seeing? Am I seeing past flowers or fruit? Those are the phenological questions, and those are the real data that we're looking at. The other thing to keep in mind is the photo is the data moving forward. So you may be standing in a field of many, many flowers, and you've taken a small photo of that location. The photo is what we're left with as data and what we would quality control and go back to look at when we're filling out these fields for you, or whether there may be some error in the data and we need to go look at that. We're going to be looking at the photo that you left behind as an observation and checking those fields. We are going to go next to an interactive piece to test out some of these questions. But first, just to remind you some of the tips about taking photos of these plants. Here's a great example of the photo not to take and the photo to take, where you can't really see the trout lily that well in that top photo. You can't fully see the flower. Whereas in the second photo, it's a great photo of the flower itself. We can see that it is open to a pollinator. And we can do a lot more with that second photo when we're going back and looking at this to QA, QC it. So some tips to keep in mind is that you want to take multiple photos of your specimen or your plant patch, including close-ups of the flower if possible. I'm not, so yes, so we'll move on to the next slide. So now I believe that Morgan is going to launch an interactive set of questions for us. And so we encourage you to scan the QR code that you see before you using your phone. And that will allow you to participate in the poll for these images. So as we move through, we're going to ask you to answer these questions around what you see in the photo. And here you're looking at the question or the phenological question of, do I see flowers or flower buds? One or more fresh flowers are open or unopened, so a bud, for example, are visible on the plant. And you would exclude any wilted or dried flower parts. So if you can scan the QR code with your phone, then you can participate in the poll and we can see how people do. This is a really easy one to get us started and going on. So we can see the results coming in. Nobody's fooled by this picture that it is a beautiful open flower of red trillium. So we're going to advance in a minute, I think, maybe. Okay, this is the next phenophase question that you will get asked in our project when you make an observation. So the first question was, do you see flowers or flower buds? This one is, do you see open flowers? And that's a different question because really what this is about is the flower open and accessible to a pollinator? So can you see the reproductive parts, the stamen, the pistil? So this is, yes. Again, we're not fooling anyone with this easy question. And honestly, we selected the phenological phases that we thought would be the easiest for people to answer because we don't want to make this too hard of an exercise. So I would say that what is great about this project, though, is that this does provide real data across, as she showed, an incredible stretch of latitude and allows us to collect data that we can't be everywhere collecting. So it's really an excellent way for us to get more coverage spatially because Morgan can't be everywhere. And she is very busy at the two locations where she has plots. So percent of fresh flower is a trickier one. It's not in this example because there's only one flower and it is open. But when you do a percent of all fresh flowers on the plant, you do want to only count fresh parts. If you see some petals have fallen off, and it's what we're going to see in the next slide, which is past flower, you don't want to count that in the percent of fresh flowers. And so that's something to keep in mind when you answer this question. So everybody's doing a great job. The next one I think is a little bit trickier once we get away from, oh, okay, so we're going to do past flower for red trillium. Do you see any past flower in the photo? And that would be when one or more of the paranth or basically the flower petals have wilted or fallen off. And the ovary in the center may begin to swell or change color. And again, people are pretty savvy on this. And this is one of our easier species to look at. It has a really interesting fruit, red trillium. It looks like a Hershey's Kiss, but in a dark ruby red color. All right, next question. Okay, so this is quite a different looking species. It's blue cohosh. And what do you see here? Getting a little harder to answer. Do you see flowers or flower buds? One or more fresh, open, or unopened flowers are visible. Yep, folks are right on target here. We are looking at fresh flowers. Great, next one. So do you see open flowers? One or more of the flowers are open. Indeed, we do. Next. Okay, this is probably a little trickier. What percent of all fresh flowers on the plant are open? And again, fresh flowers are only parts that are the fresh parts. And Morgan and I actually didn't talk about this one ahead of time, so it'll be interesting to see what she and I both say. I do see what I think is some flower buds on there, but I also see other structures that are not flowers anymore. So they are past flower, giving away the next one, but they are not buds or unopened or open. And so I would lean towards the 75 to 94% myself, because I do think I see flower buds on there, but I mostly see of the flower material fresh. So that's a good one so this is where it gets tricky. This is probably the trickiest question of all the questions that you have to answer in the project. So, and this is also something that we work hard to curate. So we will go back and into observations and help to correct anything we think is off. But it'll be good to hear what Morgan thinks on this one. But I think it's 75 to 94%, because I think I see some flower buds in there. Next. So past flower. So yes, I agree with this. We are seeing that you can see straggling of where the flower used to be, and there's left behind a green structure that's probably the ovary that's beginning to swell. And what's interesting about this is you also see other parts on this. So I think everybody got this question right. Yes, we do see past flower. And this is not the only species that we have that has multiple phenophases at a time, like pretty consistently. So that is something to keep in mind. We are going to get multiple phenophases on some of these plants. Canada Mayflower is also a species that does that quite a bit. Okay, next. And then this last one's a little tricky. This is bloodroot. Do you see any fresh flowers? Do you see any flowers or flower buds? Excuse me. Yep, I think people are on track here. Next image. I think this is our last image or question. Do you see fruit? One or more fruit at any stage of maturity visible on the plant? Yep, and I think the majority wins here. That is a fruit structure that's sticking up that looks like a pea pod. That is and one of the great ways to learn the stages of the plants is to go on iNaturalist and just look at all of the bloodroot images that are there already. It's an incredible library, basically, of these plants in different stages. Okay. Next. All right, just some final tips and reminders. We're really looking to get a lot of observations in the spring. It might be that some of the spring is past in your neck of the woods, but certainly still unfolding here. We just got actually a cold snap up here. Try to take multiple pictures per observation. Remember to double check the time and the location and that accuracy of the location. And then when in doubt, you can leave a question mark. And there's a huge community, not just us, but a large community on iNaturalist that will help you identify the plants. And certainly we will help with the phenophases. And so just a reminder to stay on the trails and leave no trace when you're out there. Oh, and curation is the last pitch. We often have a need. I've been talking about us curating and quality controlling. So if you are interested, there's my email. Contact me if you are interested in helping us do a lot of that online quality control work that we need to do along the whole Appalachian Trail. So many observations. This is just one species, round-lobed hepatica. There's over 3,000 observations ready to be curated and added to the project. Next. So here's some links. We can share that in an email after the webinar as well, so that you can have access to all of this information. Questions?
All right, that was fabulous. I'm also going to pop in, we do have a question, so we'll read that in a second. I'm going to pop in the National Phenology Network website as well, because that's a great way to get some training and some information on the phenophases. It's been a while since I've jumped into that website, but they do a really great job of offering educators materials for students of all ages and families that want to get out and start observing a single tree in their schoolyard or their yard, and just getting used to paying attention and providing observation. So, all right, we do have a question from Claire. She asks, when you record the data for the phenology of these wildflowers, what and how many parameters are you tracking? Is it about the overall health of the plants, or tracking how many buds open, or how many flowers are produced per plant, or the diversity of species per plot?
Yeah, I can start off because Morgan does a lot more with the data, but the way it's designed is those questions we just went through are really the parameters that we are collecting on each observation. So it's really about what stage the plant is in. And then when you put all of these data together, we get a better sense of the distribution, and the geospatial information really helps us get a sense of, those different phases at different elevations, at different latitudes. We're not really collecting information on the health of the plants per se, but collecting it year after year as well is a really important temporal component to the data that allows us to understand in a warmer spring or a cooler spring, and eventually in the context of climate change, how they're responding.
Any other questions out there? Feel free to drop them in the Q&A. I have one. If you were offering folks to come and help curate, like what would that entail? What would you have these folks doing? Because it's pretty enticing, but I'm expecting it's very detailed, right?
Right. It is. It's a little labor intensive because it is, but what we try to do is assign one or two plants that you really enjoy looking at. But it's going through and finding observations that are within the corridor and adding it to the project, and then adding those phenophases. And so it could be as, bringing on iNaturalist, observations aren't research grade unless they've had multiple observers agree on a identification. And so that's one part of the curation, is moving observations up to research grade so that we can use it in our research. And then there's assigning the phenophases, which a lot of times people leave out because they're just not certain, or they're just on their hike and they're not going to spend the time to fill out those fields. So it's really a lot of hunting around for these observations, getting them in the project, getting the phenophases filled out. And like I said, the amount of observations already in iNaturalist, thousands for some of these species that have yet to be put in our project. So that's really the big piece. The big lift is the volume of data, because it is a crowdsourcing app. So
Yep, and we had another question come in. This is actually my husband on the line. Can the photos be deleted from our phone after they have been loaded to the app without affecting the data?
Yes, after it's been uploaded. So it does kind of clog up your photos because it does put it in your photo library. So what the easiest way to deal with that is to log out of the app and back in. Once you know that they've synced with the server, basically that you know they've all been uploaded, you can log out of the app and they all sort of disappear out of your photo library. Log back in, you're back in business for another set of plants. So it is something to keep track of, and it may work differently on Androids, but that's what we found on the iPhone.
Yeah, I think we're going hiking this weekend.
Thanks.
And I'm really wanting to bring you all back next year or maybe next summer to see if that heat map has changed. So, because it is really interesting, that gap that is in the mid-Atlantic for observation. So we'll really shake the trees and try to get some activity going on with this recording or this presentation and then the recording, and making sure that people are reminded in February and March next year, hey, remember this is an option. It's really valuable. It's useful. And if folks haven't seen any kind of presentation about phenology and climate change, that's a really exciting and interesting thing to tap into. I know NPN has done that a few times, and it's really amazing what they can put together from those data. So yeah, great stuff. Anything from the Shippensburg team or anybody else? Oh, we do have another question. What is the time frame you want the pictures taken?
It can be super flexible. So as Georgia mentioned, we are specifically interested really in those early spring events, right? Like when do you see that first trout lily leaf or that first trout lily flower? But observations can be added in any time. So for the purposes of my project, I'll probably be doing a lot less modeling of fruiting phenophases, but that's great data too, right? When is blue cohosh? When are those fruits ripe? If you see that, great to snap an observation and upload it. And I very well may integrate that data. So it can be really flexible, even in the middle of winter, you could see a remnant of a plant sticking up above the snow and add that into the project if you want. And I want to just mention too, I think we said it, but just to emphasize it, that really any species can be added to this project, right? So we have a set of target species that we're interested in, but you can add observations of any organism along this trail corridor, and it provides a really incredible atlas and library of the organisms from many different parts of the kingdom of life. So it doesn't have to be just spring wildflowers. So a lot of flexibility there.
And value if there's insects or any other critters using the plant too, I would expect, right? Yeah.
Yes, and I will make a push for, if you do see insects on the flowers, please take their photo as well. There is one project that is across the Northeast, or it might be just New England, so maybe a bit out of your reach, but basically looking at pollinators on plants and iNaturalist. And that's the other thing, is like one observation can go into iNaturalist. It can serve our project, it could serve their project. It can be multiple data points for different projects. So it's really a great tool to collect this information.
And notes if it's being chewed upon and, other kinds of observations like that. Yeah. Another question, are submissions of the same plant at different points on the trail helpful?
Morgan, do you want to?
Yeah, they certainly can be. It sort of depends how far apart on the trail. So for the purposes of the modeling that I'll be doing with these data, the scale of the climate data that I'll be using is about 1/2 kilometer at the finest resolution. So any observations that you put in that are closer than 1/2 kilometer to one another are somewhat redundant. Although, if you see two different plants next to one another on the trail and they're showing different phenophases, right, that's important information to capture. So it is very context dependent. But for the purposes of this project, think more on the scale of kilometers than feet.
Yeah, and I
Great.
generally
Good to
say
know.
every 1,000 feet in elevation, it's always good to capture that variability going up.
And do you want only native plants or any species?
Yeah, really, really any species. So for the purposes of our iNaturalist project, we're really interested in native or naturalized plants. So, we don't want you to add photos from your garden. But apart from that, invasive plants are an important part of our ecology, and understanding their distribution and phenology is an important component of the work that needs to happen. So the more the merrier.
Yeah, and some of the different kinds of native plants, they're going to pop out under that and catch that sun way earlier than some of our other plants. So they take advantage of that lack of canopy to further their life cycle fairly quickly and fill the forest with green before the leaves pop. Okay.
I want to ask a question or clarifying point. And Georgia talked about the corridor and side trails and the use outside of that. How broad of an area outside of really the AT corridor is the primary focus?
So the project was set up using the National Park Service had created a corridor based on the Huck 10 watershed size. So it's a hydrological unit of Huck 10, which I can't tell you how big that is right off the top of my head, but we decided to use that as, we had to have a boundary at some space, but we felt like that provided a good elevational gradient. It's on a watershed basis. And so that is what we're using as the sort of buffer around the actual treadway.
Yeah, and I'll just jump in to add that it's pretty wide. It does vary a bit in width, but just to give you a sense, Shippensburg University itself falls within the Huck 10 watershed of the Appalachian Trail corridor for the purposes of our project. So, yeah, I think at least like 10 or 20 miles on either side of the AT, you're likely to fall within it.
So those side scenic trails are definitely part of that.
Yes.
Yeah. Yeah. Any other questions for Georgia and Morgan? That's all I'm seeing in the Q&A, and it's 7:03, so that's great timing. I want to thank everybody here, everyone who's attended, all the team that's provided backup and support to help create this. We will be sending out the resources, the recording, and any other information that we can provide to you. Please feel free to email us at theclues@ship.edu. And we've got Georgia and Morgan's email address on the recording as well. And yeah, feel free to reach out, jump on iNaturalist, and let's find it and let's take those pictures. We do have a very short survey for the end of the program as an evaluation. This helps us plan this one and for future programs. So really, really appreciate your feedback. So feel free to jump on that, and our tech guru will launch that here shortly. So thanks everyone, and everyone have a great evening and get out on the trail.